Let me ask you something. When was the last time you looked at a place and thought, this doesn't look real? Not an edited photo, not a movie scene, an actual place. Because there are parts of our planet that do exactly that. They confuse you. They feel like they don't belong here. A lake that's completely pink. A desert that looks like the surface of Mars. Caves where life has never seen sunlight. And that's just the beginning. In this episode, we're going to explore 20 of these places. 20 real environments where nature seems to have ignored every rule. But here's the interesting part. None of it is random. Every unusual color, every strange shape, every unlikely creature has a reason. And once you start to understand these places, well, they stop feeling alien and start revealing something much more interesting: how far life can actually go. There's a common assumption we tend to carry, that the planet has already been fully explored, as if everything has been seen, mapped, and understood. But that's not entirely true. There are still places on Earth that don't quite fit the pattern. Landscapes that confuse you at first glance. Colors that feel too intense to be natural. Shapes that don't follow any obvious logic. And the most interesting part isn't just how they look, it's what happens in them. Because surviving in these environments isn't simple. It never is. Each one comes with its own set of rules. Sometimes it's extreme heat. Sometimes it's cold. In other cases, it's the absence of light, water, or even too much of it. And yet, life still finds a way to exist. Just not in the way we expect. As we move through these 20 places, something starts to become clear. These hidden paradises aren't just beautiful or strange. They're tests. Tests of how far life can adapt. And if this kind of discovery pulls you in, it's worth sticking around. Because there's still a lot about this planet we're only beginning to understand. And it all starts with two places that look like they were painted, but weren't. The first place feels like a mistake. A shade of pink so intense it doesn't seem natural, spreading across the landscape as if someone spilled paint over the water. But it's not paint. This is Lake Hillier in Australia. And what makes it even more unusual is that the color doesn't change. It doesn't depend on lighting conditions, the time of day, or even the weather. The color is in the water itself. And that challenges a basic assumption we have about how nature works. When you look closer, it stops feeling like a mystery without explanation. It becomes a result of very specific conditions. The salt concentration here is extremely high, creating an environment where almost nothing can survive. But almost nothing never means nothing at all. Microalgae like Dunaliella salina thrive in these conditions, producing reddish pigments that help protect them from intense solar radiation. It's a direct response to a problem. And when millions of these organisms exist in the same space, the entire lake takes on that striking color. It's not aesthetic. It's not accidental. It's adaptation, working exactly as it needs to. The second paradise shifts the scene completely, but follows the same underlying logic. In southern Bolivia, the landscape transforms into layers of color that don't seem natural at first glance. Deep reds, yellows, and orange tones spread across the terrain as if painted in broad strokes. This is the Dali Desert. Here, life isn't what defines the environment. Geology is. Over millions of years, minerals like iron, sulfur, and copper have been exposed to the surface, reacting with the atmosphere and creating this unusual visual effect. But even in a place like this, where altitude exceeds 4,000 meters and oxygen levels are low, life still finds a foothold. In scattered salt lagoons, flamingos feed on microorganisms that are capable of surviving in these harsh conditions. And what's even more interesting is that those same organisms directly influence the color of the flamingo's feathers. It's a subtle but constant relationship, or the environment shapes life, and life, in turn, reflects the environment. Two completely different landscapes, one driven by microscopic organisms and the other by geological processes, yet both following the same fundamental rule. The more extreme the environment, the more precise the adaptations need to be for life to continue. The third paradise doesn't reveal itself right away. To reach it, you have to go down. And the deeper you go, the more everything begins to change. Light starts to fade, colors slowly disappear, and eventually, everything is swallowed by darkness. This is the world of deep cave systems, an environment where life has never depended on sunlight, and that changes everything. The rules we're familiar with simply don't apply here. Vision, for example, becomes irrelevant. Some fish species that live in these caves are born without functional eyes, not because they lost them, but because they never needed them in the first place. Maintaining something useless comes at a cost, and in an environment where energy is limited, every detail matters. Instead, these organisms develop other ways to navigate their surroundings. They become sensitive to vibrations, to subtle shifts in water movement, to changes that we wouldn't even notice. Insects appear pale, almost translucent, moving slowly, conserving energy with every action. Nothing is wasted here. Every movement is calculated, every function optimized. And even without light, life continues, supported by minerals and organic material carried in through water from the surface. It's not an abundant system, but it is stable within its own conditions. The fourth paradise moves in the opposite direction, but the challenge is just as extreme. Here, the problem isn't the absence of light, it's the overwhelming presence of it. In some of the driest deserts on Earth, the sun dominates everything. During the day, surface temperatures rise to levels that make survival nearly impossible for most living creatures. And because of that, the landscape appears empty. But that emptiness is misleading. Life hasn't disappeared, it's waiting. Beneath the sand, under rocks, inside small crevices where the heat is less intense, animals remain hidden, conserving energy until conditions shift. And when the sun sets, everything changes. Activity begins. This is when the kangaroo rat emerges, a small mammal that perfectly represents the logic of this environment. It doesn't rely on drinking water directly. Instead, it extracts all the moisture it needs from the seeds it consumes. Its body is designed for efficiency. Its kidneys minimize water loss. Its metabolism is adapted to conserve every possible resource, and its behavior avoids unnecessary exposure to extreme heat. Even its movement is optimized. Quick jumps, unpredictable direction changes, all designed to escape predators in a matter of seconds. Survival here isn't about strength, it's about precision and efficiency. The third and fourth paradises represent two absolute extremes, one where light never reaches and another where it never relents. And yet, in both environments, life not only exists, it finds a way to persist. And at this point, something important starts to become clear. Nature doesn't operate under a single set of rules. Each environment creates its own conditions, and life responds with solutions that aren't always obvious at first glance. After environments where everything feels limited, the fifth paradise shifts the challenge in a completely different direction. Here, the issue isn't scarcity, it's excess. This is the heart of the Amazon rainforest, but not the open aerial view most people are familiar with. This is the dense interior, where the canopy is so thick that sunlight barely reaches the forest floor. At first glance, it might seem calm, almost still. But that impression doesn't last. In reality, everything is happening at once. The ground is in constant motion, not visibly, but biologically. Layers of leaves, branches, and organic debris fall continuously, and almost as soon as they touch the ground, they begin to break down. Insects, fungi, and bacteria work without pause, co-transforming that material into nutrients that feed the entire system again. Nothing stays in place for long. Nothing is wasted. It's a continuous cycle, fast and efficient, where abundance doesn't mean stability, it means constant transformation. Within this environment, the pangolin appears, one of the most unusual mammals on the planet. Its body is covered in hard, overlapping scales that function as protection. But what truly defines it is not its appearance, it's its specialization. Instead of competing for more common food sources, it focuses almost entirely on ant and termite colonies. And when it finds one, it uses a long, flexible, sticky tongue to reach deep into spaces that other animals simply can't access. In just a few minutes, it can consume thousands of insects. It has no teeth, but that's not a disadvantage. Its digestive system is adapted to process food in a different way, using internal structures that compensate for that absence. Every part of its biology serves a clear purpose within this environment. It doesn't try to compete broadly. It succeeds by being precise. The sixth paradise takes this idea of abundance and shifts it beneath the surface of the ocean. Coral reefs function like living cities, dense ecosystems where space is limited, but life is everywhere. Fish, crustaceans, mollusks, and microscopic organisms occupy every available niche. Movement is constant, interactions are continuous, and everything is connected. But what truly sustains this entire system isn't immediately visible. Inside the coral itself, microscopic algae live in a close relationship with their host. These algae perform photosynthesis by converting sunlight into energy, and in return, they provide nutrients that allow the coral to grow and build complex structures over time. It's a precise exchange, one that supports an entire ecosystem. When this balance holds, the reef thrives. When it's disrupted, the system begins to collapse. Corals lose their color, weaken, and with them, the countless species that depend on them begin to disappear. The fifth and sixth paradises reveal something important. Abundance doesn't guarantee security. In fact, it depends on balance. Every organism, every interaction plays a role. And as this journey continues, it becomes clear that even the most vibrant ecosystems rely on conditions that are constantly shifting, often in ways that aren't immediately visible. After environments where life seems to expand in every direction, the seventh paradise shifts the experience completely. Here, everything slows down. The landscape is dominated by white, sound feels muted, and movement is minimal. This is the Arctic, a place where cold isn't just a condition of the environment, it's the foundation of everything that happens. Every action carries a cost, and wasting energy without a clear outcome can make the difference between survival and failure. On the ice, the polar bear moves with a kind of calm that isn't accidental. It doesn't chase prey over long distances or rely on speed. Instead, it observes. It identifies specific points in the ice where seals surface to breathe, and then it waits. It can remain completely still for long periods, conserving energy while staying alert. When the moment comes, the movement is fast and precise, but it doesn't always succeed. And in this environment, failure has real consequences. Every missed opportunity means energy lost in a place where recovery is never guaranteed. But there's another factor that constantly reshapes the rules. The ice itself is unstable. It shifts, breaks apart, reforms. Areas that seem solid one day can disappear the next. Hunting routes change, distances expand, and what once worked may no longer be reliable. Nothing here is truly fixed, even if it appears that way at first glance. The eighth paradise faces the same cold, but approaches it in a completely different way. In Antarctica, survival is not an individual effort, it's a collective one. Penguins gather in large colonies, and when temperatures drop even further, they form dense groups that move slowly as a unit. This movement isn't random, it's a system. The individuals on the outer edge face the harshest wind and cold, but over time, they rotate inward, allowing others to take their place. This constant exchange distributes heat across the group, creating a shared advantage that no individual could achieve alone. There's no visible leader, no centralized control, but the outcome is remarkably efficient. Meanwhile, beneath the frozen surface, another world continues uninterrupted. Fish adapted to sub-zero waters move through an environment that would freeze most other organisms. Their bodies produce specialized proteins that prevent ice crystals from forming in their blood, allowing them to function where others simply couldn't. The seventh and eighth paradises show two different strategies for dealing with the same extreme condition. One depends on individual precision, the other on collective coordination. And if you're following this journey closely, something becomes clear. These places aren't random. Each one operates under specific rules, and what comes next pushes that idea even further. After an environment where cold defines every decision, the ninth paradise shifts the challenge in a way that's less visible, but just as demanding. Here, the limitation doesn't come from the ground or the temperature. It comes from the air itself. At extreme altitudes, like those found in the Himalayas, oxygen levels drop significantly, turning something as simple as breathing into a constant effort. The body feels it almost immediately. Movements slow down, coordination changes, and even basic actions require more energy than usual. But even in these conditions, life doesn't disappear. It adjusts. In the sky, birds like the condor offer a clear example of efficiency in this environment. Instead of fighting against the conditions, they use them. Rising air currents move along the mountain slopes, and these birds position themselves within those flows, gliding for long distances without the need for constant wing movement. It's not about strength or speed. It's about understanding the environment well enough to reduce effort. On the ground, adaptation happens in less obvious ways. Mammals that live in these regions have developed internal systems capable of processing oxygen more efficiently. Their blood carries it more effectively, their lungs function differently, and their entire physiology is tuned to operate under conditions that would overwhelm most other species. These changes aren't visible at a glance, but they're happening constantly. It's supporting every movement, every decision. The 10th paradise shifts the scene once again, but keeps the same underlying idea. In the vast steppes of Central Asia, the landscape appears simple, almost empty. Flat terrain stretches for long distances, with few natural barriers and little visual variation. But that simplicity is misleading. The climate changes quickly. Temperatures can shift dramatically. Winds remain constant, and distances are large enough to turn even small movements into extended efforts. In this environment, the saiga appears, a species that seems unusual at first glance, but makes complete sense when observed closely. Its distinctive nose isn't random. It functions as a filtration system, cleaning the air from dust, regulating temperature, and helping the animal cope with constant environmental changes. yet every feature serves a purpose. What's even more striking is that this species has persisted for thousands of years, surviving alongside animals that no longer exist. But that persistence doesn't mean stability. Small changes in environmental conditions can disrupt the balance quickly, sometimes with dramatic consequences. And that reveals something essential. Adaptation isn't permanent. It's an ongoing process, one that depends on conditions that are always shifting. The 9th and 10th paradises show that even in environments that seem stable on the surface, life is constantly adjusting beneath it, responding to pressures that aren't always visible, but are always present. After environments where survival depends on air, distance, or constant change, the 11th paradise introduces a different kind of pressure. Isolation. When an ecosystem remains separated from the rest of the world for long enough, evolution begins to take its own direction. Patterns shift, behaviors change, and over time, life starts developing solutions that don't always resemble what we see elsewhere. Few places illustrate this as clearly as the islands of Komodo in Indonesia. At first glance, the landscape doesn't seem extraordinary. Dry terrain, scattered vegetation, heat that remains constant throughout most of the year. But there's a presence here that completely reshapes the balance of the environment. The Komodo dragon, the largest living lizard on Earth and one of the most efficient predators in a space where competition is limited. Its strategy isn't built around speed or long pursuits. It's based on timing. It observes, positions itself, and strikes when the conditions are right. But what makes it truly effective isn't just the attack itself. It's what happens after. Its bite introduces compounds that begin to weaken the prey over time. The animal escapes initially, but it doesn't get far. The dragon follows, slowly, patiently, relying on the process to unfold. Hunting here isn't a moment, it's a sequence, and time becomes part of the strategy. This level of specialization doesn't exist in isolation from the rest of the ecosystem. It influences everything around it. Other species adjust their behavior, their movement patterns, their responses. The entire system evolves under a set of conditions that are unique to that space. Without outside interference, these patterns continue, shaping outcomes that might seem unusual, but function perfectly within that environment. The 12th paradise takes isolation even further, but in a completely different direction. Not across land, but into depth. The deep ocean is one of the most isolated environments on the planet. As you descend, light fades quickly and then disappears entirely. Beyond that point, the world changes in ways that are difficult to imagine. There is no sunlight, no familiar color, no sense of day or night. And yet, life is present. But it doesn't follow the same rules. Many organisms generate their own light through bioluminescence, producing brief flashes in the darkness, sometimes to attract prey, sometimes to communicate, sometimes to defend. Every function is precise. The shapes themselves tell another story. Bodies designed to withstand pressure that would crush most surface life, flexible structures, exaggerated features, or in some cases, the complete absence of what would otherwise be essential. And that pressure defines everything. It isn't an obstacle to overcome, it's the baseline condition. When you compare these two environments, an isolated island and the depths of the ocean, a pattern begins to emerge. When life is separated long enough, it doesn't just adapt within familiar limits. It begins to redefine them. After environments shaped by isolation and depth, the 13th paradise shifts the focus to something far more visible, but no less extreme: color. Not as decoration, but as a direct signal of environmental conditions. In northern Tanzania, there's a lake that, from a distance, can appear calm, even inviting. Its surface reflects deep reddish tones, and the surrounding landscape feels quiet, almost still. But that impression doesn't hold for long. This is Lake Natron, one of the most chemically extreme environments on Earth. The water here is highly alkaline, with pH levels that can approach those of corrosive substances. Temperatures in shallow areas can rise dramatically, creating conditions that limit most forms of life. And yet, it isn't empty. Flamingos use this lake as a breeding ground, and that choice is not accidental. The same harsh conditions that make the environment difficult also reduce the presence of predators. What seems hostile becomes a form of protection. But there's another layer to this place that makes it even more unusual. The chemical composition of the water can preserve organisms that come into contact with it, hardening tissues and maintaining their form over time. It creates scenes that appear frozen, yet as if moments have been fixed in place, not by intention, but by the nature of the environment itself. The 14th paradise shifts the experience again, but keeps the same underlying principle of adaptation. In certain coastal regions, the ocean can emit light at night, not from reflection, not from an external source, but from life itself. Millions of microscopic organisms respond to movement by producing brief flashes of blue light. Each wave, each disturbance, even the movement of a passing animal leaves behind a luminous trace. This phenomenon, known as bioluminescence, isn't just visual. It serves a purpose. In some cases, it attracts larger predators toward whatever caused the disturbance. In others, it confuses or distracts. It's a response shaped by interaction. When you place these two environments side by side, one defined by chemical intensity and the other by biological light, a consistent pattern begins to emerge. Life doesn't respond in a single way. Each environment presents a different set of challenges, and the solutions are always specific, often unexpected, but never random. After environments where adaptation becomes visible through color or light, the 15th paradise introduces something less immediate, but just as powerful: time. Here, life doesn't disappear, it pauses. Death Valley in the United States is one of the most extreme environments on Earth in terms of heat and aridity. For long periods, the landscape appears completely lifeless. Dry, cracked ground stretches across the horizon with no visible signs of activity. It gives the impression that nothing can survive here for long. But that impression is incomplete. Beneath the surface, life is still present. It's just waiting. Seeds remain buried in the soil for years, sometimes decades, without germinating. They're not dead. They're inactive, holding potential. And what determines when they emerge isn't a single condition, but a precise combination. Rainfall has to reach a certain level, temperatures must align, and timing plays a critical role. When all of those factors come together, the transformation is immediate. Within days, the desert floor shifts from barren to vibrant, covered in blooms that seem completely out of place in such an environment. It doesn't last long, but it doesn't need to. It proves something essential. Life doesn't need to be constantly visible to persist. It just needs the right moment. The 16th paradise approaches the idea of transformation differently, not by hiding life, but by altering perception itself. Salar de Uyuni in Bolivia is one of the flattest surfaces on Earth. During the dry season, it appears as an endless white expanse with almost no visual reference points. Distance becomes difficult to judge. Scale becomes uncertain. But when a thin layer of water covers that surface, everything changes. The sky reflects with such clarity that the horizon disappears completely. There's no clear distinction between above and below. The environment becomes a continuous visual plane, disorienting in its simplicity. Walking across it feels less like moving through space and more like floating within it. And even here, in what appears to be an empty environment, life continues to exist. Microorganisms adapted to high salinity survive in these conditions, and during certain periods, the species like flamingos return to feed, taking advantage of the temporary balance created by water and mineral concentration. When you look at these two paradises together, a pattern becomes clearer. Not every environment reveals itself all the time. Some operate in cycles, others depend on very specific conditions to become visible. And if this kind of discovery is pulling you in, there's still a crucial part of this story left to unfold. After environments shaped by timing and perception, the 17th paradise introduces something more dynamic. Movement. Not occasional movement, but continuous, large-scale motion that defines the entire ecosystem. The Serengeti in Africa is not just a landscape. It's a system in constant flow. Every year, millions of animals move across these plains in one of the largest migrations on Earth. But this isn't random. It's a response. Rainfall determines where vegetation grows, and vegetation determines where herbivores go. Wildebeest, zebras, and other grazing animals follow this shifting pattern across vast distances, always moving toward the next available resource. And they're not alone. Predators move with them, not blindly, but strategically. Lions, hyenas, and other hunters don't rely on chance. They anticipate movement, position themselves along these routes, and wait for the right moment. Everything is connected. There's no single point where life happens. It's distributed across space, constantly shifting, constantly adjusting. The system doesn't depend on stability. It depends on motion. The 18th paradise carries this same idea into a completely different environment. The open ocean. From the surface, it can appear empty, almost featureless. No clear landmarks, no visible structure. But that perception is misleading. Beneath the surface, everything is moving. Ocean currents transport nutrients across vast distances, creating invisible pathways that life depends on. Microscopic organisms drift in massive quantities, forming the base of entire food webs. Larger species, like whales and sharks, follow routes that may seem random, but are in fact shaped by temperature, food availability, and oceanic patterns that are constantly shifting. Even schools of fish move as a single coordinated system, reacting almost instantly to changes in their surroundings. One shift, one signal, and the entire group responds in perfect synchronization. Survival here isn't about holding a position. It's about understanding the flow and moving with it. When you look at these two paradises together, one on land and one in the ocean, the pattern becomes clearer. Life doesn't always adapt to a fixed place. In many cases, it adapts to constant change. And that introduces a different way of understanding ecosystems. They aren't defined only by what they are, but by what they continuously do. After understanding that life can depend on constant movement, the 19th paradise shifts the focus to something less visible, but just as powerful. What happens beneath the surface? Yellowstone in the United States looks unstable at first glance. Steam rises from the ground. Pools of water display intense and unusual colors, and certain areas reach temperatures that seem incompatible with life. But what truly defines this place isn't what you see. It's what's happening below, and constant geothermal activity shapes the entire environment. Heat from deep within the Earth rises toward the surface, interacting with minerals and transforming water into a chemically active system. The result is a landscape filled with thermal pools that range in color from deep blue to vivid orange and yellow. But those colors aren't just visual features. They are indicators of life. Microorganisms known as extremophiles inhabit these waters, each adapted to very specific temperature ranges and chemical conditions. Every color represents a different type of organism, thriving exactly where it can survive best. It's a precise system where life doesn't resist extreme conditions. It depends on them. These organisms don't exist despite the heat and chemistry of the environment. They exist because of it. The 20th paradise takes this idea even further, but on a broader scale. It's not a single location, but a type of environment found in different parts of the world. Active volcanic regions, places where the Earth is still shaping itself in real time. Lava flows, ash-covered landscapes, extreme heat, surfaces that have only recently formed. At first glance, everything suggests destruction, but that's only part of the story. What follows is just as important. As volcanic activity decreases, a process begins. Slowly at first. Simple organisms, like bacteria and lichens, are the first to appear. They colonize bare rock, beginning the transformation of the environment. Over time, these organisms alter the surface, allowing more complex life forms to establish themselves. It's a gradual process, but a consistent one. What once appeared completely lifeless begins to develop structure, then diversity, and eventually a functioning ecosystem. It's life building itself from nothing. When you look at these final two paradises, the pattern comes full circle. From a pink lake shaped by microorganisms to entire ecosystems forming on volcanic rock, the same principle applies. Life doesn't follow a single path. It adapts, reorganizes, and takes advantage of whatever conditions are available, even in places that seem completely uninhabitable at first. After moving through all 20 of these environments, something begins to shift in the way we see the planet. What initially seemed like a collection of strange and isolated places starts to reveal a deeper pattern. These aren't exceptions, they're variations, different ways life responds to specific conditions. And that changes how we define what's possible. Because life doesn't require perfection, it requires opportunity. The right balance, even if only for a moment, is enough. Whether in total darkness, extreme heat, low oxygen, or constantly shifting environments, life continues to find a way forward. And that leads to a larger question. How many other places like these exist, functioning quietly, beyond our full understanding? Because even now, the planet is far from fully known. There are still systems, still environments, still interactions that we haven't completely uncovered. If this journey changed the way you see nature, it's worth continuing to explore. Because this is only a small part of what's out there. There's still a lot left to discover. So now I'm curious, which of these places surprised you the most?